how to construct Newton divided difference table for the given data, and also you have learned that how to use Newton's divided difference interpolation formula to get interpolation polynomial for our functional values at some value of x for given table values. Similarly, you can observe that this formula, that means Newton divided difference interpolation formula, is also applicable even when the given functional values are at equally spaced values of x. So this means that this formula is applicable when the functional values are given at equally spaced values of x or at unequally spaced values of x. Similarly, in today's class, we shall derive another formula called as Lagrange's interpolation formula. Lagrange's interpolation formula. When the values of the function y is equal to f of x are given at unequally spaced values of x, here we can say that this formula is also applicable even when the given functional values are at unequally spaced values of x or equally spaced values of x. Now, let us see that how to derive Lagrange's interpolation formula. First, we are going to see the derivation of Lagrange's interpolation formula. Let the function be y is equal to f of x. You know that x is an independent variable, y is dependent variable, and x values are given like x0, x1, x2, and so on, xn. So there are n plus 1 x values are there, x0, x1, x2, and so on, xn. So now, similarly, these x values may be here, these x values may be equally spaced or unequally spaced values. Now, what are the corresponding values of f of x? The corresponding values of f of x are at x0, f of x value is f of x0. At x1, f of x value is f of x1. At x2, f of x value is f of x2, and so on. At xn, f of x value is f of xn. So these are the x values. These are the f of x values. So these x values may be equally spaced or unequally spaced values. Now we can assume that f of x is a polynomial. In variable x of degree at most n. So now, suppose the polynomial of f of x is f of x is equal to here we are assuming the polynomial of f of x. F of x is equal to a naught x minus x1 x minus x2 into and so on into x minus xn plus a1 x minus x0 x minus x2 and so on x minus xn plus another term a2 x minus x0 x minus x1 and so on x minus xn plus and so on plus an, the last term, x minus x0 x minus x1 and so on x minus xn minus 1. Now in this polynomial you can observe that this is the first term. This is the first term. So this is for a0. So a0 is the coefficient of this one. In these factors, x0 should not appear. So for a0, x0 should not appear. So in this term, so according to these factors, so x1 should not appear. In the second term, x1 should not appear. So the coefficient of these factors is a1. And if we coming to the third term, in the third term, the coefficient of these factors is a2. So in the third term, so x2 should not appear and so on. The last term is the coefficient of these factors is an. Okay. So now in this term, xn should not appear. So x minus xn will be there. So xn should not appear, so that x minus xn factor should not appear. So xn minus 1 is the preceding value of xn. So this is the assumption polynomial of f of x. So you can observe that where a0, a1, a2 and so on an are all constants. These are all constants. Now we concentrate on finding the values of these constants a0, a1, a2 and so on an. So that now we have to find the values of a0, a1, a2 and so on comma an. So to find the value of a0, we have to put x is equal to x0 in equation 1. Give equation number 1 for this one. So that is why this is equation number 1. So put x equal to x0 in equation 1. We can get the value of a0. So for that, take x equal to x0 in equation 1. What will you get? In the first term, so f of x becomes f of x0 is equal to a0. So next the factor is x0 minus x1 and x0 minus x2 and so on x0 minus xn. And coming to the second term, if you take x equal to x0 in this term, a1 into x0 minus x0, x0 minus x2 and so on x0 minus xn. So x0 minus x0 is 0. That is why the second term will become 0. In the same way, if we take x equal to x0 in this term, third one, so here you get x0 minus x0. So it becomes 0. The term will become 0. So that is why both second and third terms become 0. Similarly, the last term, if you take x equal to x0 in this term, so this also will become 0. That means x0 minus x0 factor will be there. So anyway, if we take x equal to x0 in this equation 1, so all the terms will become 0 except the first term. So that is why we have f of x0 is equal to a0 into x0 minus x1, x0 minus x2, and so on, x0 minus xn. So from this one, we can have a0 value. So that is a0 is equal to so I go to take another page. So a0 is equal to, what will we get, ma? A0 equal to?
F of x naught by x minus x naught minus x1.
By, what is the remaining one? X naught minus x1, x naught minus x2, so on, x naught minus xn. So this is a0 value. Similarly, we can get the value of a1 by putting x is equal to x1 in equation 1. We get, so observe this one. Take x equal to x1 in equation 1. So x equal to x1. That means x1 in the first term, x1 minus x1 factor will be there, so that the first term will become 0. If you take the second term, we get a1 into x1 minus x0, x1 minus x2, and so on, x1 minus xn will become. And in the third term, we will get a2 into x1 minus x0, x1 minus x1. So x1 minus x1 factor will be there. So that is why this term will become 0. And similarly, if we take the last term, if we take x equal to x1 in this one, an into x1 minus x0, x1 minus x1. So anyway, x1 minus x1 factor will be there. So this term also becomes 0. So that means except the second term, all the remaining terms are become 0 when x equal to x1. So that is why if we take x equal to x1 in equation 1, we can write it as f of x1 is equal to f of x1 is equal to, so what is this one, ma?
A1 of x1 minus x0.
A1 into x1 minus
x0.
x1 minus x2, and so on, x1 minus x0. Now from this one, we can get a1 value, that is a1 is equal to f of x1 divided by, in the numerator, we can get this one. x1 minus x0, x1 minus x2, and so on, x1 minus xn. Now, similarly, by putting x equal to x2, we can get a2 value. And by putting x equal to x3 in equation 1, we can get a3 value. And so on, by putting x equal to xn in equation 1, we can get an value. So directly, we can write all these values following the above two sentences, that is a0 value and a1 value. So now, similarly, putting x equal to x2, x3, comma, and so on, comma, xn in equation 1, we get a2 is equal to, tell me, ma, what is a2? According to a0 and a1 values, follow the same procedure. So observe a0 value, f of x0 in the denominator. And if you come to the numerator, if you come to the denominator, so x0 will be there. Okay, this is for a0 value. And x1, x2, and so on, xn are there. So what is x0 is there, x1, x2, and so on, xn is there. So like this manner, for a1 value, so in the numerator, f of x1 is there. So according to this one, for a2 value in the numerator, f of x2 will come. Is it right, ma? In yes, the denominator, what will you come?
x2 minus
x0. x2, and so on, x2 will come definitely. And what are the remaining values? x0, x1, x3, and so on, xn will come as in the form of factors. x2 minus x0, x2 minus x1, x2 minus x3, and so on, x2 minus xn, like this. And so on, we can get an value. So that is an is equal to f of xn by, here, this is an value, xn will come. xn, and so on, xn will come. And the remaining values are x0, x1, x2, and so on, xn minus 1 values will come as in the form of factors. xn minus x0. The second one is xn minus x1. And the third one is xn minus x2, and so on. The last one is xn minus xn minus 1. So xn is there. So the remaining factors will come like this. So these are the values of a0, a1, a2, and so on, an. So anyway, we got all the values, a0, a1, and so on, an. Now we have to substitute all these values in equation 1. Now, substituting the values of a0, a1, a2, and so on, an in equation 1, we get what is equation 1? Take another page for this one. F of x is equal to, so what is equation 1? a0 into x minus x. What is the first term in equation 1?
a0 into x minus x.
X minus x1, x minus x1, x minus x2, and so on, x minus xn. Now substitute a0 value. What is a0 value? F of x0 by, what is the denominator term? x0 minus x1, x0 minus x2, and so on, x0 minus xn. Is it right? Plus, what is the another term? Second term, a1 into something, that is x minus
x0,
x minus x2, and so on, x minus xn divided by into a1. What is a1? F of x1 divided by, what is the denominator term?
x1 minus x0.
1 minus x0, x1 minus x2, and so on, x1 minus xn. Similarly, we can write another term also, and so on. Plus, last term, an into something. What is that? X minus x0, x minus x1, x minus x2, and so on, x minus xn divided by, an. An means f of xn divided by, what is the expression in the denominator? xn minus x0, xn minus x1. You can write that, and so on, xn minus xn minus 1. Like this. So this is the f of x after getting the values of a0, a1, and so on, an. So now you can observe this one. What is this one? In the first term, f of x0 is there. In the second term, f of x1 is there, and so on. In the last term, f of xn is there. So in the first term, so x0, this is related to x0. So x0 value should not appear in the numerator. That is, there is no x0. Only the remaining values are coming, x1, x2, and so on, xn. So similarly, in the new denominator, x0 will come. X0, x0, x0 like that. So this x1, this x1, this x2, this x2, this xn, this xn, same, these are all like this. So now you can observe in the second term, this is related to x1. This is related to x1. So x1 value should not appear in this term, in the numerator. The remaining values are will come x0, x2, and so on, xn. So x1 will appear, should be appear in the denominator, x1, x1, x1. So now the remaining values are x0, x2, and so on, xn, like that. Similarly, in the last term, this is related to xn. Xn should not appear in the numerator. The remaining values should be appear like that, x0, x1, and so on, xn minus 1. In the denominator, xn should be appear, xn, xn, and so on, xn. So the remaining values are x0, x1, and so on, xn minus 1. So this is the formula. This formula is called, this is known as Lagrange's interpolation formula. So this formula is called Lagrange's interpolation formula. It can be used whether the values are equally spaced or unequally spaced values. Now, in this formula, if we denote f of x0 by y0 and f of x1 by y1 and so on, f of xn by yn, then give equation number 2 for this formula. Then the formula 2 or the Lagrange's formula 2 takes the form as f of x is equal to, so this is same, this is same, this is same. Only the difference is here y0 will come, here y1 will come, here yn will come, like that. So according to this one, write down the formula f of x is equal to x minus x1. Write down same, x minus x2, and so on, x minus xn divided by x0 minus x1, x0 minus x2, and so on, x0 minus xn into y0. The second term is x minus x0, x minus x2, and so on, x minus xn divided by x1 minus x0, x1 minus x2, and so on, x1 minus xn, here y1. And similarly, and so on, plus the last term is x minus x0, x minus x1, and so on, x minus xn minus 1 divided by xn minus x0, xn minus x1, and so on, xn minus xn minus 1 into yn. Like this. So this is the Lagrange's interpolation formula. So now here you can observe one thing. The accuracy of Lagrange's interpolation formula is same as that of Newton divided difference interpolation formula, which we have discussed in previous class. But what is the difference between Lagrange's interpolation formula and Newton divided difference interpolation formula? These two formulas are using by finding the polynomial for to the given data. So what is the given data? X values may be equally spaced or unequally spaced. So to find the polynomial for the given data, by using Newton's divided difference interpolation formula, we have to construct Newton's divided difference table. But if we coming to the Lagrange's interpolation formula, this is also useful for finding the polynomial to the given data. So now, what is the difference here? There is no need to construct any kind of table. So directly we can substitute the values from the given tabular values, x values, given x values and given y values. Only here we are going to substitute x values as well as functional values in the formula to get the required polynomial or functional values at some value of x. Only the difference is in the Lagrange's interpolation formula, directly we can substitute the values from the given tabular values. But in Newton divided difference interpolation formula, to find it, we have to construct divided difference table. Okay. So according to this one, we can say that Newton's divided difference formula is easy than the Lagrange's interpolation formula in the simplification concept only. That means we can say that Lagrange's interpolation formula is simple and easy to remember. Formula is also easy to remember. But the calculation is some difficult. In this formula, the calculation is some difficult than the divided difference interpolation formula. The difference is same, but the accuracy, suppose there is the problem to find the polynomial, we can use any formula. But if you use this formula or that formula, you can get the same result. That means the accuracy is the same. There is no any difference. So for the problem, we can use any formula. There is no difference to get the accuracy. The same accuracy we will get by using both the formulas. The difference is only the simplification is some difficult in the Lagrange's interpolation formula than the Newton's divided difference interpolation formula. Now, I think we go to take examples according to the Lagrange's interpolation formula. So see the example here. For that, I will take another page. Using Lagrange's interpolation formula to obtain the polynomial interpolation to the following data. What is the following tabular values are given here? X values, f of x values. So what are the x values are 0, 1, 2, 4. The y values are f of x values 1, 1, 2, 5. Now, so using this given data, we have to find the polynomial by using Lagrange's interpolation formula. So go to take solution. So given that x naught values and y naught, x values and y values. What are the x values? X naught, x1, x2, x naught value, x1 value, x2 value, x3 value. X naught is equal to 0, x1 is equal to 1, x2 is equal to 2, and x3 is equal to 4. Similarly, f of x values are f of x naught 1, this is f of x naught, this is f of x2, f of x3, f of x naught, f of x1, f of x2, f of x3. F of x naught, f of x1 is 1, f of x2 value is 2, f of x3 value is 5. These are the given values. Now, we have to find the polynomial using Lagrange's interpolation formula. So, in the Lagrange's interpolation formula, there are n plus 1 terms according to x0, according to x1, and so on, according to xn. F of x0, f of x1, and so on, f of xn. Anyway, there are n plus 1 terms. So, in that formula, how many terms we have to take according to this problem? So, it depends on the given values. How many values are there? x0, x1, x2, x3. How many values are there, ma? 4. 4. So, according to 4 values, we can write the formula like this. The Lagrange's interpolation formula for 4 points. For 4 points data is 4 points means from x0 to x3. F of x is equal to, what is the first term? What is the first term according to 4 points? That means x0 from x0 to x3. What is the first term? x0, x1, x2, x3 is there in this formula. According to that, in the first term, x0 should not appear. That is x minus x1, x minus x2, x minus x3. X minus x4 will come or not, ma? Is x4 value in the problem?
No, madam.
No.
Only x3 is there.
Only up to x3. In the denominator part, what will come? x0 minus x1, x0 minus x2, x0 minus x3. So this is f of x0 into f of x0. The first term is related to x0 and f of x0. Remember this. Okay. So now the second term plus the second term is related to x1 and f of x1. F of x1, x1 and f of x1. So x1 should not appear in the numerator. The remaining values should appear. X minus x0, x minus x1 will come or not, ma?
No.
No, madam.
X minus x0, x minus x2, x minus x3. x1 should appear in the denominator. x1 minus x0, x1 minus x2, x1 minus x3. x1, 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 f of x1. This is related to x1, f of x1. The remaining values are x0, x2, x3, like this. These are same. This one, this one, this one, this one. These are same. Next. So what is the next term in the third term, which is related to x2? F of x2. x2 and f of x2. So what is the formula, ma? X minus x0, x minus x1, x minus x3. In the denominator, x2 minus x0, x2 minus x1, x2 minus x3. Is it right?
Yes, madam.
Right? Next. What is the next term? It is related to x3 and f of x3. So x3. X minus x0, except x3, all the values should come in the numerator. X minus x0, x minus x1, x minus x2, x minus x3 should not come. Next, x3 will come in the denominator. x3 minus x0, x3 minus x1, x3 minus x2. F of x3. So, is there possible to get another term according to given data?
No, madam.
No, only up to x3 values are there. So, we can write the formula like this. F of x0, f of x1, f of x2, up to f of x3. 1, 2, 3, 4. 4 terms will come. Only 4 values are in the given data. So, now we have to substitute all these values, x0 values, x0, x1, x2, x3 values, f of x0, f of x1, f of x2, f of x3 values in this formula. Substitute all the values in this formula. So I'm going to take another page. So substitute f of x is equal to x minus x1. What is x1? 1. X minus x2. What is x2? 2. X minus x3. That is 4. Divided by x0. x0 is 0. Minus 1. 0 minus 2. 0 minus 4. F of x0. What is f of x0? 1. 1 plus next term. X minus x0. x0 means 0. X minus x2. 2. X minus x3. 4. Divided by x1. What is x1? 1. 1 minus 0. 1 minus 2. 1 minus 4. So f of x1 value is 1. Next, plus another term, x minus x0, x minus x1, that is 1, x minus x3, that is 4, divided by x2. What is x2? 2. 2 minus 0, 2 minus 1, 2 minus 4 into f of x2 plus x minus x0, 0. X minus x1 is 1. X minus x2 is 2. By x3 value. x3 is 4 minus 0. 4 minus 1. 4 minus 2. And f of x3 value is 5. Like this. Now we have to simplify this one. This is equal to, what is the first term? X minus 1, x minus 2, x minus 4 divided by minus 1, minus 2, minus 4. Into 1, that is 1. Plus second term, x minus 2, x minus 4 divided by 1, minus 1 into minus 3 into 1, that is 1. Plus next term, x minus 1, x minus 4 divided by 2 into 1 into 2 into 1 into minus 2 into 2. Or you can write like this. Plus last term, x into x minus 1 into x minus 2. 4 into 3 into 2 into 5. 4 into 3 into 2. Now again we have to simplify this one. So what is the value? First simplify x minus 1 into x minus 2 into x minus 4. Minus 1 into minus 2, 2. 2 into minus 4, minus 8. Minus 8 is there. So simplify this one more, x minus 1, x minus 2, x minus 4. Simplify this one and tell me what is the cube root. Cubic equation will come. Quadratic cubic equation will come. Cubic polynomial. Simplify this and tell me what is the answer. X minus 1 into x minus 2 into x minus 4. X squared minus x minus 2x minus 3x plus 2. X minus 4. Now again simplify this one. X cube minus 3x squared plus 2x minus 4x square minus plus 12x minus plus into minus 8. Okay, now simplify this one. X cube square minus 3 minus 4 minus 7x square. X plus 2, 12 plus 2, 14x minus 8. Is it right, ma?
Yes, ma'am.
What is this? X cube minus 7x square plus 14x minus 8. So plus next one. Next one, what is this? X minus 2 into x minus 4 into x divided by 1 into minus 1 minus 1. Minus 1 into minus 3, 3. So simplify this one, ma. X minus 2, x minus 4 into x. So,
X cube minus 8x square plus 8x.
X cube minus
8x square
8x square
plus 8x.
I think I have doubt here, ma. X square minus 2x minus 4x minus 6x plus 4 2 jar 8 into x. X square minus 6x cube minus 6x square plus 8x. Is it right, ma? Minus 6, ma. Is it right?
Oh, okay, ma'am. Sorry.
X cube minus 6x square plus 8x by 3. Another term. Next one. 2 into minus 2. Minus 4. So x minus 1 into x minus 4 into x. X minus 1 into x minus 4 equal to x square minus x minus 4x minus 5x plus 4 into x. So this value is x minus 5x square plus 4x. Is it right, ma?
Yes, ma'am.
Yes, madam.
Next. Into 2 will be there. 2 get cancelled. Minus 2 will come only. Okay. Next. So according to this one, x minus 1 into x minus 2 into x. So that means x minus 1 into x minus 2 is this one. So into x means x cube minus 3x square plus 2x by 5.
24.
24 into 5.
Okay.
Okay. So this is now also again we can simplify this one. Simplify, ma. Go to take another page. So this is f of x is equal to take common 1 by 24. 8, 3, 2, 24. So you can take common 24, ma. You can simplify this one. If we take common 1 by 24 or LCM 24, 8 3s are 24. So multiply the first one into 3 minus 3. Minus 3x cube minus plus 21x square minus 14 3 are 42x minus 3 into minus 8, 24. So from the second term, we can have 3 8 jar 24. 8x cube minus 8 6 jar 48x square. 8 into 8 64x. Next, plus the third term 12 2 jar 24 minus 12 minus 12 x cube minus minus plus 12 5 jar 60 x square minus 12 4 jar 48 x plus the last term is x 24 1 jar 24, that is x cube minus 3x square 5 this last one into 5 will be there, ma. 5
Yes, 5
minus 15 15x square plus 5 2 jar 10x. Again, you can simplify this one. 1 by 24 into minus 3x cube plus 8 plus 5. Minus 3 plus 8, 5. 5 plus 5, 10. Minus 2 minus 2 minus 2 x cube. Next, x square terms 21 plus 21 minus 48 plus 60 minus 15. Do this, ma. Tell me value. Plus 21 plus 60, 81. 48, 15. 63 minus 63. 8, 1. So 18 plus 18x square. Is it right, ma?
Yes, ma'am.
Yes.
Next, take the x terms. Minus 42. Next, plus 64. Next, minus 48. Next, plus 10. 74. This one. So 80, 10, 90. Minus 90.
Minus 16x, ma'am.
Yeah, minus 16x plus remaining one 24. Constant terms, only 24, like this. Now, simplify this one. You can take common from all the terms. So you can get 1 by 12 minus 1 by 12 x cube plus 3 by 4 x square, 18 by 24. So 6 3 jar, 6 4 jar minus 16 by 24. 2, 8 2 jar, 8 3 jar x plus 24 by 24, 1. F of x is equal to minus x cube, x square, x. So this is the polynomial of degree 3 by using Lagrange's interpolation polynomial. Next, I will take another example. By using Lagrange's interpolation formula. Using Lagrange's interpolation formula to find f of 5. That means x equal to 5 here. To the following given data. X values, f of x values are given. So x values are 1, 3, 4, 6. F of x values are -3, 0, 30, 132. Solution. So here we have to find the value, functional value at x equal to 5. So from the given data, we have to find the value of f of x at x is equal to 5 by using Lagrange's interpolation formula. So now I will take another page. So from the given data, given data, x naught is equal to 1, x1 is equal to 3, x2 is equal to 4, x3 equal to 6. And f of x naught value is -3, f of x1 value is 0, f of x2 is 30, f of x3 value is given as 132. So these are the x values and f of x values. x0, x1, x2, x3, f of x0, f of x1, f of x2, and f of x3. So now how many values are there in the from the problem? x0, x1, x2, x3. 4 values. According to the 4 values, we have to take the Lagrange's interpolation formula as above example. So in the above example, in that given data, the x values are 4. In this problem also the x values are 4. So the same formula we can apply. So anyway, the Lagrange's interpolation formula for 4 points of the given data is f of x is equal to, so write the formula. First, compulsory we have to write the formula. X minus x naught, x minus x1, x minus x. So x naught will come or not in the first term? No.
No, madam.
x1, x2, x3 divided by x naught. X naught will come in the denominator. X naught minus x1, x naught minus x2, x naught minus x3. This is related to first term, f of x naught. Plus the second term is related to f of x1. So f of x1. So you can write like this. F of x1. X minus x naught, x minus x2, x minus x3. x1 minus x naught, x1 minus x2, x1 minus x3 into f of x1. Next term, x minus, this is related to f of x2 and x2. x naught and f of x minus x1, x minus x2 should not come, or x3 will come. x2 should come here only. x2 minus x naught, x2 minus x1, x2 minus x3 into f of x2. Plus this is related to x3 and f of x3. So x minus x naught, x minus x1, x minus x2, x minus x3 should not come here, and x3 should come in the denominator like this. x3 minus x0, x3 minus x1, x3 minus x2 into f of x3. So this is the first term, second term, third term, fourth term. So now substituting, we have to substitute all the values in the formula. So what is the x value from the problem? X is equal to 5. At x equal to 5, we have to find f of x value. Is it right? So according to this one, we have to find f of x at x equal to 5, that is f of 5. So anyway, what is x ma? 5. So take x is equal to 5 in this formula and take all the values x0, x1, x2, x3, f of x0, f of x1, f of x2, f of x3 in the formula. So then you can get the value. Next, go to take another page. Substitute ma f of x. What is x ma?
5 made.
To find f of 5. So this is required value, f of 5. And substituting all the values in the formula, x minus x1, x means 5, x1 means 3. X minus x2, 5 minus 4. X minus x3, 5 minus 6, divided by x0 minus x1. What is x0? 1. 1 minus 3, 1 minus 4, 1 minus 6 into f of x0. F of x0 is minus 3. Plus, so go to take next term. Second term, x minus x0, 5 minus 1. X minus x2, 5 minus 4. X minus x3, 5 minus 6. By x1 minus x0. What is x1? 3. 3 minus 1, 3 minus 4, 3 minus 6. F of x1 value is 0. Plus next term, x minus x0, that is 5 minus 1, x minus x1, that is 5 minus 3, x minus x3, that is 5 minus 6, by x2 minus x0. What is x2? 4. 4 minus 1, 4 minus 3, 4 minus 6 into f of x2. F of x2 is 30. Plus last term, x minus x0, 5 minus 1, x minus x1, 5 minus 3, x minus x2, 5 minus 4, divided by x3, 6. 6 minus 1, 6 minus 3, 6 minus 4 into f of x3, 132. Now we have to simplify this one. F of 5 is equal to, in the first term, 5 minus 3, 2. 5 minus 4, 1. 5 minus 6, minus 1. Divided by minus 2. Minus 3, minus 5 into minus 3. Is it right, ma? Plus, what is the second term? What is the second term?
4 into
4
into 1 into
minus 1
1
into
by
2 into minus 1 into minus 3 into 0. Plus third term, 4 into 2 into minus 1. 3 into 1 into minus 2. into 30 plus last term 4 into 2 into 1, 5 into 3 into 2 into 132. So now you can observe this one, it becomes 0, the second term. So now minus 3 is there. Minus 3 will get cancelled. The remaining one is this one, minus 2 divided by minus into minus plus 5 into 2, 10. Next one, plus 3 2s are 6, 6 5s are 3 2s are 6, 6 5s are. So here is minus minus plus, minus minus plus, 4 2s are 8, 8 5s are 40. Next, plus this one. 3 2s are 6. 6 2s are 12, 22. Okay. Next, this value is, this is 5. 4 2s are 8. 22 8 jar by 5. What is 22 8 jar, ma? 176. So therefore, this value is, take LCM here, 10. Minus 2 plus 400 plus 5 2 jar 10. 176 into 2 jar. $352 by 10. So now tell me what is this value, ma? 400 plus 352. 752 minus 2. 700. 750. Sorry, 750 by 10. This value is 75. F of 5. Is it right, ma?
Yes, ma'am.
So this is the finding the functional value at some value of x, that is x is equal to 5, by using Lagrange's interpolation formula. So in the examination, they will specify find the interpolation for polynomial by using so-and-so formula or so-and-so formula, like that. Or if they are not given, if they are not specify the formula, you can choose the formula according to the given problem. Suppose in the problem, x values are not at equally spaced values, definitely you have to choose the formula, Newton's divided difference formula or Lagrange's interpolation formula. If x values are given at equally spaced values, you can choose the Newton's forward difference, backward difference or central difference formulas. So there is how we can choose Newton forward, backward, central difference. So if you want to find at middle value of x, you can choose central difference formulas. So at end value of x, you can choose backward. At the starting value of x, you can choose the forward difference. So at middle value, you can choose, there are many central difference values. You can choose according to the value of u, which I have explained to you. Have you any doubt, ma?
No, ma'am.
No,
Now
ma'am.
I am going to give another problem. You have to do this problem, ma. The problem is here. Example. Do yourself using Newton's divided difference interpolation formula to estimate the value of log 1.2 to the given data. X values, f of x is here log x. Log x values are given like that. 1.0, log x value is this one. 1.4, at this value log x value is this one. 1.5, at this value log x value is this one. 2.0, at this value log x value is this one. Do yourself, Uma. First, what will we do? Take x values and y values from the given data, tabular values. Okay. What are the x values and y values? This is x0 value. This is x1 value. This is x2 value. This is x3. So this is f of x0. This is f of x1 value. F of x2. This is f of x3 value. So these two are given values. First, you have to write the formula according to the 4 x values. x0, x1, x2, x3. Only 4 values are given. According to these 4 values, what is the Newton divided difference interpolation formula? Newton's. Write down first. Given that x values, x0, x1, x2, x3, like that. Write down. F of x0, f of x1, f of x2, f of x3. Write down all these values from the problem. Okay. Now, Newton's divided difference interpolation formula is f of x is equal to f of x0 plus x minus x0 into f of x0 comma x1 plus x minus x0 into x minus x1 f of x0, x1, x2 plus x minus x0, x minus x1, x minus x2 f of x0, x1, x2, x3. Can we go for another term? Is there possible? No. x0, x1, x2, x3 values are given. Up to here, we can stop here. The formula, we can stop up to this term. X minus x0, x minus x1, x minus x2. So this is the Newton divided difference formula. So what is this value? We know that x0, f of x0, x1, f of x1, like this, we know that all these values. What is this value? What is this value? And what is this value? How can we get it, these values? How can we get it, ma, these values?
F of x0, x1 is equal to f of x minus f of x0 divided by x1 minus x0.
Oh, okay, that's what I am going to say, that we have to construct divide difference interpolation formula as I have explained and in the previous class, ma.
Yes, madam.
What is the message? Somebody has given the message that last class E chapter varaki finish ayindi. చెప్తారా మేడం? ఎలా చెప్పాలి ఇప్పుడు? ఎవరమ్మా?
Madam, I am Bhagya Lakshmi. Actually, last 2 classes I didn't listen.
Okay.
So that's why I asked. Not yours, madam. Who are there in
how can I give you the lecture according to the previous classes? If you come to the department in the university, I will explain to you and I will give you the information, ma. Okay. Otherwise, how can you give?
Not I asked not you, madam. I asked who are they, madam. The friends I asked to friends. Ask to them.
Yeah, you can know, you can take the notes from your classmates.
Okay, madam. But there are different places are. We are from Kurukla, madam. Jaitya district.
Okay.
Nobody is there near by us.
Okay. So I don't have any PDF. If I have PDF, then I will give you. Otherwise, so no, mas this I explained on the board now. So there is not like this material. I don't have this material in the form of PDF. So I cannot give you. So anyway, if you come to the class if you come to the department, I can give the information or I can give explanation part.
Okay, madam.
If we have.
Okay, madam.
Okay.
Madam, ekkadiki Karimnagara lekapothe branch
University, Ambedkar Open University, Hyderabad.
Okay, madam. Okay. Thank you, madam.
So, are you doing construction of the table, divided difference table, or shall I tell you? Follow the same procedure which I have explained in the previous class. I have given one example according to the Newton's divided difference interpolation formula. I have given the table, how to construct the table. According to that, you have to construct the table first. Then only from the table, you can have the values. This value, and this value. Anything else, ma?
No, madam, we will do that process only.
Do this problem yourself.
Ma'am, ఈ 2 classes లో ఇంపార్టెంట్ వి చెప్తారా?
Okay, ma.
Okay, ma'am.
Do you have your book, ma, numerical methods?
Yes, ma'am.
Next class, I will start another chapter.
Okay, ma'am. అంటే ఇంకా 2 classes ఉన్నాయి కదా, టైం సరిపోదేమో అనేసి.
2 classes, I will complete 2 units, ma. So already in previous 2 classes, I didn't attend that. So if possible, I will take my 2 classes again. Huh?
Okay.
Only 2 classes will be there, and the remaining 2 classes, that means 4 classes. If possible, I will take that 2 classes also. Then I will have 4 classes. So,
Okay, madam.
4 units. I hope 4 units. I will try to complete 4 units after 4 units. Next. In the first unit, ma'am. In the first unit.
Finite differences.
In the first unit, page number 15. Page number 15. 16. 15 and 16. 2 problems will be there. And 17. 17. One more problem is there. And 19 is there. So from these 4 problems, definitely one problem like the problems will come. That means Newton's forward formula, Newton's backward formula. From these 2 methods, at least one, definitely one problem will give.
4, 5, 6. Out of 4, 5, 6 examples, madam.
If you do one example, you can do other example, whichever they have given.
Okay.
Whichever, because so first you have to know how to use this method, forward difference interpolation formula or backward difference interpolation formula. Remember the formula and apply that formula, but that the procedure is same. So do one problem thoroughly. So whatever the example will be there, you can do that problem if you know the proper method. Okay.
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 Forward difference, use the forward difference formula or use the backward difference formula. So there are, do the 2 problems. For example, example 5, page 16 is there. Example 5, page 16 is there. For example, this is important.
Okay.
Similarly, example 15, example 4, page 15. This is for forward difference formula related to. But problems are important. Example 5 and example 6 mark. These 2 problems are important problems. Example 5 is related to backward. Example 6 is related to
Backward.
Y40. Y40 means related to backward. Forward. Related to forward. You can use any formula. That means you can use any formula for this. So like this problems, important. Next, you coming to the central differences. Gauss forward, Gauss backward is there. So example 8, page 23. Do one problem related to one method and remember that formula. So definitely you can do the problem, whichever example they will be given. Remember that point, please. Page number 23, example 8. Page number 24, SAQ 8. And similarly, page number 25, example 9. And page number 26, SAQ 9. Example 8 and SAQ 8 are same. Example 9 and SAQ 9 are same. So any one problem will come. Important problems. And similarly, page in example 10, page number 27. Stirling's formula problem. Gauss forward or Gauss backward or Stirling's. These three formulas, any one definite, at least one will come definitely. Gauss forward or Gauss backward or Stirling's formula. These three formulas, remember the formulas, definitely at least one from these three will come. So do one example according to the one formula. So the problem, whatever it may be the problem, so you can do that problem by using that method, that formula, like this. So I will give you one more suggestion to you and list out all the formulas. Newton's forward difference interpolation formula and write the formula. Newton's backward difference interpolation formula and write the formula. When we use this formula at end of the values of x, just little bit note, one sentence, little bit you have to write. So list out all these formulas like that. So you can directly, you can choose that paper, so that read that formula and any problem they can give, you can do that. Next, divided difference or Lagrange's interpolation formula. Do one example, at least one example for each formula or each method. So definitely one problem will come out of these two methods, divided difference or Lagrange's interpolation. I think 90% divided difference is important. Examples are given in your textbook. At least one you have to do, and you can do any problem, whichever the problem they will be given, you can do that. So but first you have to know how to apply this formula. When we can apply this formula. So remember these 2 points and definitely then only you can get the problem in the examination. Like that. Okay, ma.
Excuse me, ma'am. Assignment paper lo Newton's interpolation formula annaru. Test book lo వేరే లాగుంది. మీరు చెప్పింది రాయొచ్చా?
Newton's interpolation forward or divided difference? They didn't mention, ma.
మెన్షన్ చేయలేదు మేడం.
Newton's x values ఏంటి? X values equally spaced or unequally spaced?
ఓకే మ్యామ్.
ఒక్కసారి ఈక్వల్లీ స్పేస్డ్ అన్ఈక్వల్లీ స్పేస్డ్?
ఏమీ లేదు మేడం, జస్ట్ ఫార్ములా రాయమని చెప్పారు. న్యూటన్స్ ఫార్ములా రాయమన్నారు,
డిరైవ్ చేయమన్నారు.
డిరైవ్ ది న్యూటన్స్ ఫార్ములానమ్మా?
అవును మేడం.
న్యూటన్స్ ఇంటర్పోలేషన్ ఫార్ములా.
ఓకే, అదే న్యూటన్స్ ఇంటర్పోలేషన్ ఫార్వర్డ్ ఆర్ బ్యాక్వర్డ్ దే డిడెంట్ మెన్షన్. ఓకే, I will tell you next class, ma.
Okay, ma'am. Thank you.
Okay, I will see and I will tell you.
Okay, ma'am.
Okay.
Thank you so much. Thank you so much, madam.
Assignment, you have to submit my assignments to your center, in your center. Okay?
Okay, ma'am.
Okay, ma'am.
Okay, ma. I am going to leave.
Okay. Thank you very much.